we will discuss speed of escape or escape speed, or sometime also known as escape velocity. Actually, the term escape velocity is wrong because it has nothing to do with escape from the surface of the planet. So actually, the correct term must be speed of escape or escape speed. But since this is also used escape velocity, so I'm getting with that also. Now, what is that? How the definition is? First of all, suppose this is the surface of the planet. And this is the radius of the planet, or its mass is m. Now, this is its gravitational field, and this is the point of infinity. First definition which I define, there are two definitions. The first one is easier, second one will be difficult, but second one is the more conceptual is concerned with this name. So, but the first one is an indirect definition. I will say what is the speed of escape. I will say definition. Its first definition is, I will say, when an object is released from point of infinity, then the speed by which it strikes the surface of the planet is called speed of escape on the surface of planet. It means, suppose if an object of mass m is released from point of infinity, then it will be hitting this the surface of this thing, and what the speed it hits with the surface will be known as speed of escape, or v escape, or velocity of the escape, or escape speed. So that is one definition. This indirect definition, for example, suppose this is any object, and it is released from the point of infinity towards the earth. Now, speed of escape of the earth is 11.2 kilometers per second. I will prove it later on. So, it means when this object is released from point of infinity, it will hit the surface of the earth with a speed of 11.2 kilometers per second, and hence it will be known, this will be known, 11.2 kilometers per second is known as the speed of escape on the surface of the earth. Okay, but this definition doesn't convey the name or the concept of this thing. So another definition is, but this is the best definition I think. Another definition is, it is the initial minimum speed. The word initial and minimum are must. It is the initial minimum speed of the object from the surface of the planet due to which it will go away from gravitational field of the planet without help of rockets or by other manual means. These words are very important because now according to this definition, it is the initial minimum speed. Initial minimum speed, it must be minimum, it's initial. Means afterwards, not this speed, it's the initial one which is required from the surface, suppose Earth. It's the initial minimum speed of the object from the surface of the planet, due to which it will go away from the gravitational field of the planet without help of the rockets or by other manual means. It means suppose this is the Earth, and if I throw the body from the earth with a surface of 11.2 kilometer per second, it will never return to the earth. It will reach the this point of infinity. So it is just that where the gravitational field is zero. So I can say this is the initial speed. Now, and also it's the minimum. Minimum in a sense, because suppose if you throw this body or object with a speed of suppose 12 kilometer per second, it will even go away from the gravitational field of the earth, but there's 12 kilometer per second will not be the speed of the escape, because it's not the initial and minimum. It will be initial, sorry, it will not be minimum. It will go away from the surface, but the minimum speed will just it will reach the where the gravitational field is zero. So it is the minimum initial speed. But without help of rockets, if suppose if you attach rockets and you are providing sufficient fuel, then always if even the body goes with 5 meters per second constant speed, it will take million of years it can take, but it will go away from the gravitational field of surface. The common sense suggests. So it should be without the help of other manual means or without the help of rockets. I can calculate, I can drive the formula for speed of escape just by using the work energy equation. Actually, if this point I am taking as A and this point is B, I can write EP at A plus EK at A plus work done will be equal to EP at B plus EK at B. So I can write EP at B, it's just the surface of the planet, I can write minus GMM upon R, where this G is universal gravitational constant, M capital is mass of the planet, and M small is the mass of the object, and R is the radius of the planet, plus EK at A, it must be the kinetic energy like this one, 1 upon 2 mv escape square. This is the escape speed it has, and its object mass of the object is small m, so its kinetic energy must be 1 upon 2 mv escape square. Plus work done must be 0, because only it is without help of the rockets and other things. There's no other means. Okay. Then EP at B, it has just to reach the gravitational point of infinity where there's no gravitational field. So EP will be 0, and EK will also be 0 because it has just to reach over there. So I can simplify this formula, 1 upon 2 Vm escape square will be equal to GMM upon R. So this M cancels and this V escape comes out to be 2 GM upon R under the root. Now this formula suggests another thing. It suggests that the speed of escape is independent of the mass of the object. If it is independent of the mass object, means if you are throwing this just a marker from the surface of the earth and giving the speed of 11.2 km per second, this marker will never come to earth again and will just be away from the gravitational field of earth. Similarly, if you are suppose throwing a very huge body of 1000 kg mass, okay, with a speed of 11.2 km per second, then it will also never come to the surface of earth again. So actually this mass cancels out here, so I can say this mass is cancelling out, so I will say the speed of escape does not depend upon the mass of the object. And this is one formula. I can write another thing, this I can write in this way, 2 gm upon r square into r under root. This is the same thing. It's the same thing in the way the r is cancelled with the square of r, but now this comes to value of 2 gr under root. So there are two formulas. I can write two formulas here. I will say one is here the two formulas I am writing in this is V escape is equal to 2 gm upon r under the root, r it is 2 gr under the root. What is g? It is universal gravitational constant. What is m? M is mass of the planet. Mass of the planet. R is the radius of the planet. Small g is strength of gravitational field. At surface of planet, not anywhere else. And r is the radius. So I can calculate the speed of escape on the surface of the earth, although I told you it is 11.2 km per second, but let us calculate. V escape is equal to 2 gr under the root. So it's 2 into G is 9.81 into R is 6.4 into 10 power 6 under the root, and if you want to calculate, it comes to be 11.2 kilometers per second into 3 significant figures. You can calculate it. So that is the speed of escape or speed escape velocity. Now it has nothing to do with the direction. See, suppose if a body is thrown from here with 11.2 kilometers per second, it will never come again, because this distance, although not here, this distance is constant. Distance is constant from this one because it's circular. So gravitational field is circular. So it doesn't depend upon the direction. You throw an object from here, here, here. So escape velocity is a strong term which is used, but the correct term must be speed of escape, and we can define it in two ways. First is when a ball is released from point of infinity, and the speed by which it strikes the planet surface is known as the speed of escape. Other definition is it's the initial minimum speed given to the object in order so that it can go away from the gravitational field of the planet without help of some rockets and other things, and it's the initial speed. And minimum means if you are giving it the more speed, it will never come, but it will not be the speed of escape, because speed of escape clearly means the minimum speed, and it must be initial without the help of rockets. Because if you throw anybody even 1 meter per second, if you are giving it the rockets, it will take million of years, but it will go away the gravitational field of the earth. Anybody gravitational field this one speed of escape is different for different planets, because the mass is different and its radius is different. But you know, we can drive this formula by the work energy equation. Just EP at the surface of the planet plus kinetic energy and plus work done will be 0, and EP at infinite point of infinity is 0, and also EK is 0. So from that we just drive the formulas. Okay, and we have the two relationships. One is the V escape is 2 gm upon R under the root, and other one is V escape is equal to 2 gr under the root, and we can put the values, and for any radius of the planet, and g is the value strength of gravitational field on the surface of that planet.